All right, part 2 of the video. Hopefully this one won't be as long as part 1. Part 1 kind of got long because I had a lot of definitions to get through. So where we're going to start here is we have this picture of our product cost flows. And so what we're going to do is we are going to use some numbers and put some numbers to this because you know me, I need numbers to make sense of things. So what we're going to do is we're going to take this data. We have purchases, direct labor, overhead, and beginning and ending balances. It says some of the goods sold this month were produced in previous months, and some of the goods listed below were not sold this month, and COGS does not have equal sums of the above costs. And so what we're going to do is we're going to draw the T accounts right here. So you're going to do exactly what you did at the bottom of page 2. Draw your 4 T's, and then you're going to put in everything you know and move from left to right. So let's go ahead and let's take this data and we are going to put it in here. So I am going to make a copy of this. And now I'm going to, a little bigger, I'm going to delete the numbers. Okay, so delete those numbers, or the words, I mean. Okay, and so what I'm going to do is I'm going to make this smaller so now I can see my information behind, and I'm going to put in the things that I know. Now, when I put in the things that I know, I normally start with the beginning and ending balances because I kind of like to start with those. Just putting in the beginning and ending balances makes me happy. Where are those ending balances? What happened? I'm sure they show up on yours. I don't know why they're not showing up on mine. Okay, that was weird. Okay, so I'm going to put in my beginning and ending balances. Raw materials started with 10 and it ended with 30. I know that the beginning and ending balances are debits because they're all assets. So WIP's beginning and ending, and finished goods beginning and ending. Okay. So the first thing I did was I just put in each of the beginning and ending balances into my 3 asset accounts. And so from there, I'm going to put in the other things that I know. So I put in everything that I know, and these are the items that I know. I know purchases of raw material are 200. Based on my bottom of page 2, purchases go here. When I buy raw materials, it goes into there. 3 things go into WIP. 3 things: direct material, direct labor, and overhead applied. So this will be direct material, and I always do them in order because I'm weird. And this will be direct labor and then overhead. So direct labor is 270. I don't know direct material yet. Overhead in total is 420. So my total overhead is 420. All those costs are going to go into overhead. And there's a note here about same as applied. That will be important next chapter. So the 420 goes into WIP. So 3 things go into WIP: direct material, direct labor, and overhead applied. And so what happens now is I put in everything that I know. I put in my purchases, I put in my direct labor, I put in my overhead, I put in my beginning and ending balances. And what it wants me to do is it says find the balances in total manufacturing costs, COGM, and cost of goods sold. So those are 3 different things that I need to find. And so that you'll do this in your homework too. So the first thing you're going to do is let's go ahead and solve for our unknowns. So I want to solve for the colored ones here that I do not know yet. So this number is just a raw material T account. And so I started off with 10 and I bought 200. So I think we would agree that we have 210 available and I only have 30 left. So I have 210 available. I only have 30 left. So that means I must have used up 180. So I must have used up 180 because I started off with 10 and I bought 200. So I had 210. I only have 30 left. So the rest was used up. So to do it, I'm going to do 10 plus 200 minus 30. That's how I find my direct materials. Okay. So that 180 will shift over. Okay. So whatever number comes out of raw materials, and so now I want to make my arrows significantly smaller. Okay. Whatever number comes out of raw materials will go over to, or out of raw materials will go over to WIP. So this is my direct material, this is my direct labor, and this is my overhead. And now I need to find this number. Now this number's name is COGM. Its name is COGM. COGM is not a real word, okay? It's cost of goods manufactured. It's like COGS with an M, okay? Cost of goods manufactured. It's the cost of the goods that we manufactured this period. You can find that number in one of two places. You can find it coming out of WIP, or you can find it coming into finished goods. It will always match, just like over here, okay? So to find this number, we're going to do it just like we did over here. So over here, we added these two and subtracted the 180 to get 30. We actually added these two and subtracted the 30 to get 180, okay? So we're going to add these together and subtract 30 to get 180. So we're going to add all of these together and subtract 60 to get the number that comes out. So we're going to add together all of these numbers and subtract the 60. So that number's name is COGM. Okay, so whatever comes out of there goes over to here. And so it looks like in this problem, COGM is 850. Okay, and then to find this number, same exact concept. We have 130 and 850. We only have 80 left. So looks like COGS is 900. So the cost of the good that was sold is 900. So basically, these are the goods that left the factory floor because they were completed, and we call those COGM, and this is COGS. Okay, so I'm going to take a picture of this. I'll start over. And so, and come back over here, and I'm going to put that right here. Oh, before I do that, I'm going to hit undo real quick and see. Okay, more activity, proportionally more cost. I just want to make sure I get my spacing right. Okay, so I'm going to make this a little bit smaller. Okay, so that I have some room to write a couple things. So I need to go ahead and it says find the balances of total manufacturing costs, COGM, and COGS. So COGM is easy. COGM is the number that comes out of WIP and goes to finished goods. And so it will always be that number. So it's 850,000. And then COGS, also easy, it's the 900. But total manufacturing costs, that one you have to find. And it's the total costs that we incurred this period for manufacturing. It's these three numbers added together. So total manufacturing costs are the three numbers we added to WIP. They are direct material, direct labor, and overhead. So it's 180, 270, and 420. So total manufacturing costs are, make the calculator. Oh, I don't know what that is. Okay, 180, 270, and 420. 870. So those are all things that I might ask you for as far as homework answers, okay? So I could ask you for total manufacturing costs, which are direct material, direct labor, and overhead, COGM, or I might ask you for COGS. And so you'll do that in your homework, okay? All right, so now what we've done is so going back to page 1, we've done product versus period. We've also done selling versus admin, and we've also done direct versus indirect. We now know how to calculate COGM, and we know how to find cost of goods sold that will go in the summary statements. And so we still need to do variable versus fixed. And then I think I actually took this off and moved it to another chapter. So we're getting pretty close to being done, but we do need to know how to do, how to come up with some cost equations. So I probably need to update that a little bit. Okay, so we are now moving on to variable versus fixed. Variable versus fixed won't take as much time. So I know it looks like we're not very far yet, but we're doing really good. Okay, so variable costs. Variable costs, by definition, are costs that change with changes in activity. More activity, more cost. So the more that you make, the more tires you need. So the more bicycles you make, the more tires you need. The more bicycles you make, the more handlebars you need. So COGS is a great example of a variable cost, because if I make more bicycles, I need more seats. I need more pedals. Okay. So more activity, proportionately more cost. And so here's an example. So your water bill, based on the number of gallons of water you use. And so let's assume that the cost per gallon is 2 cents a gallon. So every time you use a gallon of water to do laundry, to take a shower, let's say it costs 2 cents. I think this might help my kid to convince him to maybe not be in the shower for an hour. My 13-year-old boy likes the shower. So if you used 4,000 gallons of water in the month, what would the cost be at 2 cents per gallon? So what we would do is we would take 2 cents times 4,000, and I got $80. Okay. So you would take 2 cents, 2 cents per gallon times 4,000 equals $80. Okay. So that's how you would calculate the variable part of your water bill. Okay. So if the next month you only used 3,000 gallons, you would take 3,000 times 2 cents and it would only be $60. Okay. If the next month something went crazy and you used 40,000 gallons, then it would go up. Okay. Now my water bill is actually like progressively worse. It's like so if I get over a certain number of gallons, then it moves to more than 2 cents a gallon. So then it's like 4 cents a gallon or whatever. So it's ugly. Okay. So here is an example of what it would look like if you were to draw a variable cost like on a graph. So I'm going to come over to Excel again, come to another blank area and get rid of my grid lines. Okay. So what I'm looking at here is we make microwaves and each microwave needs a timing device. So that timing device costs $30. So every time we make a microwave, we got to put a timing device so that it dings when your food's done. And so it says the per unit and total cost at different levels of activity. So what I'm going to do, and so I'm kind of excited about it, is I'm going to do X and Y. And I'm going to graph this, you guys. And so right now you might be cringing, maybe even like crying a little, but don't, you're okay. So what I want to look at is if I make one microwave, then it would be $30 for a timing device. If I made 2 microwaves, then it would be $60. If I made, let's do 300 and 600, just as an example. So 300 microwaves, each one is $30. And 600 microwaves, each timing device, $30. So what I want to look at is what would that look like on a graph? Okay, so if I were to graph it, okay, I don't know how to, I want to draw this. I could go to the drawing thing, but I'm not going to because I'm lazy. So I could go to the drawing mechanism, but you guys, when you took math, you saw that Y is always your up and down and X is your horizontal one. Okay. This is X, this is Y, up and down. And in my world, Y will always be dollars. Okay. So what we would do is we would draw, like if I were to try to draw it, then I would make a right border and I would make a bottom border. I've never done this before. I'm just trying to see what it looked like. And so this would be Y and this would be X. Okay. And if I were to plot the points, then I would say, okay, every time this gets bigger, then my dots will get bigger. Okay. So if I said, okay, what if I sold, 100 microwaves? Well, 100 would be 3,000. And then I would draw a dot. And then I would go over to 300 and I would draw a dot. And I would go over to 600 and I would draw a dot. X comma Y. Rise over run type situation, right? So that's how you do slope later. I won't do that for a while later though. Okay, so what I want to do is I'm just going to highlight these. And so watch me do this so you can see it. I'm going to highlight these. And so Excel will make the graph for you. You do not have to graph. Excel will graph. So again, all I've done is highlight it and then I go to insert and I go over to my graphs. See my charts and graphs and stuff. I'm on the insert tab. I'm on my charts and graphs. And I'm going to go to the scatter one, insert scatter, and then I would just draw my points. Okay, so I can also see it with a line. Okay, I can also see it with a line. See how the X's went along the bottom and the Y's went over here. So I'm going to delete this for a second. And then I'm going to do insert. And here, if I do the one with a line, that one works. So the one directly below gives me a line. So look, isn't that pretty? And so if I sell 0 microwaves, it's 0. And if I go up to 300 microwaves, then I am at 9,000. And if I go up to 600 microwaves, I'm at 18,000. Okay, so that's how you would graph it. So I'm going to make this smaller, and I'm going to put it on top of that. And then what I want to do, delete that. Will that Y go away? Yeah, it would. I don't want to delete it. Okay, so I'm going to take a picture of it. And then I'll go put this in here. Okay, so where am I still cutting off? And I'm going to make this significantly smaller and get rid of spaces. So hopefully you just drew it. Then you don't have to worry about it. Okay, but I need to make it even smaller than this. Okay, there we go. Still not. It's still too big. Okay, and so the next thing we need to do is we need to do fixed costs, and fixed costs are the exact same concept. So on fixed costs, basically, fixed costs are the opposite of variable because fixed costs do not change to responses and changes in activity. So more microwaves does not make more rent. So when I made 1 microwave, then I would have a certain amount of rent. If I made 2 microwaves, my rent would be the same. If I made 1,000 microwaves, my rent would be the same. So what we're looking at is what does a fixed cost do as far as graphing? And so I want you to cross this part out. I meant to delete it. So just get rid of this. And then I kind of wish these 2 places were reversed because this is Y, rent, cost. Cost is always Y, and this is X. So if I make 1 microwave, my rent is $9,000. But if I make 10 microwaves, my rent is still $9,000. And if I make 100 microwaves, my rent is $9,000. And if I make 200, it's $9,000. So let's graph that. So I'm gonna do 1, 2, and then they had 100 and 200 there. And my rent is $9,000 regardless of the number of microwaves that I make. So if I were to graph this, then I would insert a scatter graph with line, and it would look like that. And so that's literally it. So because basically it doesn't matter if I make 1 or 200, my rent is $9,000. So let me do this. Actually, I'll do that again. Let's go with that. And go put that in here. Oh, man, sorry. I actually only need this is already in there. So, well, can I still paste? Okay, so just go like this, and I just want to see this pretty little graph like that, and I'll just go put that right here. And it's way, way, way too big. Okay, still too big. Shift it over. I think when I pasted it kind of in a weird place. So let's try this. And I can figure this part out later, and so I don't really need to worry about it, but I just kind of want that to be in the notes so that I have like a completed copy in there. And so, okay, so I'm going to move on and I'll fix that later. Don't worry about it. But I just want you guys to see that little picture next to the rent being 9,000, regardless of how many units we make. So fixed cost is B. It's B. It's your y-intercept. It's where your line starts. Okay. So fixed costs do not respond to changes in activity. It's B. And so let's say that your water bill is $20 for water hookup. That's like for your sewer charges or whatever. That's your flat fee for having water. So if I left for the entire month of December and I used 0 gallons of water, I would still have to pay $20 for a fixed cost to have the water hooked up to my house. So what if you use 4,000 gallons of water? So you have your $20, but you also use 4,000 gallons of water. What would your total water bill be? So to find your total water bill, why don't you guys hit pause and see if you can figure out what your total water bill would be if you used 4,000 gallons of water. And remember, I think it was 2 cents a gallon from the previous page, right? Okay, so what you would do is you would take 2 cents times 4,000 gallons, and you would get $80, and you would add to it that 20 of fixed cost for a total of 100. And so what you literally just did was you just took 2 cents a gallon times the number of gallons, and then you added to it the fixed cost. So would you agree that I could also write it as 100 equals 0.02 times 4,000 plus 20? So the answer is 100, and you took 2 cents times the number of gallons plus the 20. So one more way to write what I just did is y equals mx plus b. So b is your fixed cost of 20. M, I would like that not to be capitalized. I don't know if I can make it change. I guess I don't really care. So M is your variable cost per unit. For every unit of water you use, it's 2 cents. And then 4,000 is the number of water units you use, number of gallons of water you use. So if I said, what if it was 5,000? Then you would plug 5,000 in there and you'd say 5,000 times 2 cents is 120. And then your total cost would be 120. So we're going to go through and do that kind of stuff quite a bit. Okay, so the next part here, it just wants to know, this is just kind of a practice one of whether the costs are variable or fixed. Okay, so looking at these costs to find out if they're variable or fixed. The students always argue with me on all of them. But what we would say is cost of lighting the store. So we're running a Baskin Robbins, and so Baskin Robbins is an ice cream place, but if we're open, we have to have the lights on. If we're closed, we can turn off the lights. So the question is, how does this cost change with respect to the number of cones sold? So the answer on this one is fixed. And students are like, that's not right. You know, your electricity bill changes. And you are right, your electricity bill does change. But your electricity bill does not change because you're selling more ice cream cones. Okay, your electricity bill might, but not lighting specifically. You either have your lights on or you have your lights off. So if it's a February day and it's snowing and nobody buys any ice cream, you still have to have your lights on. So it is not changing because of number of ice cream cones sold. Wages of the store manager. My guess is that the manager would not be paid per ice cream cone. So I'm going to say fixed on that one as well. That person's probably on a salary, maybe $3,000 a month or whatever. Cost of ice cream, I would say variable, because the more ice cream cones you sell, the more ice cream you use. Now students are like, well, what about single dip versus double dip? And I'm like, you're right, you know, so we'd have to keep track of single versus double, but every time you sell more ice cream cones, you would need more ice cream. And then napkins, I would say the same thing. So every time you sell an ice cream cone, we give them a napkin. On average, we could say how many napkins every customer uses. More ice cream cones, more napkins. So I would say that one's variable as well. Now, I know we could argue about that as well, because like my Claire baby doesn't even need a napkin because she's super clean. But my Lauren that's 15, she needs 4 napkins because she's super messy. So depending on if it's variable or fixed, depends on how it responds to the number of cones sold. So we're almost done with fixed cost here. So fixed costs, they can be like a lot of different categories. And so fixed costs can be ones that you absolutely have to pay. Those are committed fixed costs, like rent. You have to pay your rent. But there's also discretionary fixed costs like advertising. You do not have to advertise to be able to make your goods. You do not have to advertise. It's a necessary cost, probably. It is a fixed cost, but you don't have to do it. So it's optional. Okay, so here we have our y equals mx plus b, and I know my sheet isn't lining up exactly with yours, and so I'll try to fix that when I take a break between the videos. But what I want to see here is that the b is the intercept. So if I'm looking at this particular line, it looks like the fixed cost is 500. The fixed cost is 500 because that's where it hits the line, and then this line is increasing at a constant rate, and that's the slope, and the slope is the variable cost per unit. So if I wanted to find the slope, I could identify 2 points. Like this point right here is 0, 500. And then I can look at like this point, and this is 100, and it kind of looks like about 1500. And I can try to figure out what the variable cost per unit is by finding my M. And we'll do that eventually, but not right now. So to find M, you do use rise over run. And to do that, you do y2 minus y1 over x2 minus x1, okay? And so we will do this in the part 3 of the video, okay? So mixed costs just mean it has a variable component and a fixed component. And so the example could be the water bill that had a base fee of $20 and then 2 cents per gallon. It could be like my little brother, he's paid a salary plus a commission. So his salary is the fixed part and his commission is variable. So write a cost equation for the water bill we just did. And so a cost equation, anytime you have to do a cost equation, it will be y equals mx plus b. And then what you'll do is the m is the variable cost per unit and the b is the fixed cost. So your cost equation would be y equals, and then we would say, what was it? 2 cents per gallon plus, and the fixed cost was $20. And then you could also put something like, if we were in Brenda Smith's math class, we would say, where X is the number of gallons, okay? So we could plug in however many gallons. If we had a month where we use 0 gallons, then our water bill would be $20. This is dollars, okay? And then this is units or gallons or whatever. So Y is always dollars. Okay, but we could plug in whatever we want for X. We could say we used 10,000 gallons, and we say 10,000 times 2 cents is $200 plus 20, and the answer would be 220. Okay, so this is called a cost equation. So write a cost equation for your salary if you have a fixed salary of $2,500 a month and it's a 5% commission. So 5% would be 0.05 X plus 2,500 of a fixed cost. So if you made 0 sales, then your salary would be 2,500. So I would say where X is the sales. So you would put in sales here. So if your sales were, you had sales of $5,000, then you would do 0.05 of that plus 2,500, and your total paycheck would be $2,750. If you had sales of $120,000, you take that times 0.05 and add to it 2,500, and then your paycheck would be $8,500. Okay. So this is called a cost equation, a y equals mx plus b. And so the remainder of the notes are going to be how to create those. So I'll stop here.